If you go back a few weeks, I released a video talking about the new SSMS Copilot currently in public preview that enables you to have a Copilot that has access to the database based on your SSMS connections. But an important thing I didn't talk about. What does it actually do? What is it useful for? We're going to start answering that question today with database design and management on today's chapter of Data Bard.
Data bar, 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 data bar. Dabba, 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 hoi, hoi, hoi.
Now, this is going to be a longer series, so I want to take some time to clearly identify here what are the objectives, what are the goals, and what's the game plan that we're going to have here to try and experiment with SSMS Copilot. First thing, at least I want to cover here, is what is the intention of SSMS Copilot. In short, it's a Copilot that has the same access that you do to your database environment when you're connected to a database within SSMS. That means if you think of it in terms of a RAG pattern design, this Copilot has access to your database structures, which includes everything, tables, store procedures, indexes, and the like, and then is able to use that connecting to an OpenAI endpoint, at least currently OpenAI endpoint, is able to use a RAG pattern that passes that information with a prompt into AI solutions and to give you a response, which not only includes just giving you responses in terms of a response, this is what you should do. This Copilot is also going to have the capabilities of potentially writing to your database. So things like table creation, table deletion, database optimization for things like performance tuning, indexing, things like that. It's going to have the capability to do that all as well. So with that in mind, let's talk about the goals of this series. We're going to be trying to cover a bunch of use cases that we deal with day in and day out in the database world, and I'll be looking at it especially from the lens of data engineering. With that, let's put a couple of guardrails around what we're doing to highlight at least the approach that I'm taking here. First of all, we're going to truly look at this as an experiment, not necessarily an endorsement of the product. I'll say right now, I've been working with the product for a few months now. I've genuinely enjoyed working with the product. I think it's going to have a lot of valid use cases, but this isn't just pure sales pitch. We are going to try and do a lot with this that showcases where the product is going to work well, at least in its preview state, and where it is not going to work well. So that means we're looking at this as a scientific experiment, which also means we're going to be not only exploring real use cases, things that I expect people to actually do in a real life scenario, but that means we're going to be intentionally pushing boundaries. You're likely going to be seeing me doing things in here that are considered risky. I'm going to be trying to manipulate data in an environment. I'm going to be trying to make significant changes to a database that are probably things you should not do in a production environment. So here's your disclaimer. Just because I'm doing something in this video series does not mean that I recommend doing it. It's because I want to intentionally push the boundaries here so that we can know, here's some things, yes, go ahead and go for it. Here's maybe some things that, alright, with basic intuition we can agree that it's risky, but let's see what the risk actually looks like if we try doing it here. This is all going to be done in a demo environment that I'm specifically creating for this purpose. And so big disclaimers here. First of all, don't try this in production right away. If you're going to experiment with this, make sure you're doing it in non-production environments so you don't break things from things like AI hallucination or other things that could happen anytime you're interacting with Copilot. Second thing is I'm doing this in an environment that isn't sandbox, so I'm intentionally doing this with elevated access to show some of the risks that might come up here. Obviously, that means you should be locking down your environments the way you should expect to, and the Copilot should adjust accordingly. The SSMS Copilot can never have access to anything more than your existing database connection can have. So at least that's our guardrail there. Also, final disclaimer, we're talking about this as a preview feature. It is in public preview, but it is still a preview feature nonetheless. Expect that some things will change before the product or when the product goes live. Also expect that once it goes live, this will continue to be enhanced. It's an AI model. It will need further training as time goes on. When we look at this, then we're going to try and experiment, we're going to come up with answers, and we're going to try and assess what are the trade-offs here. What would this look like if I tried to do this without AI support? What does this look like with AI support? And is the benefit of a Copilot worth the trade-off that will come with it as well? That's the goals of what we're trying to do here in this series. Like, believe me, when I created this series, I knew what likely people were going to have concerns about, and already have based on the conversations I've had with coworkers in the industry, is that there's a lot of fear around this. You want me to trust AI with a database environment, having direct access and being able to manipulate it? Yes. And I expect that to incur a lot of fear. For me too, it is something that is both exciting and concerning. That's what this series is all about. Let's address the fear, let's see what happens, and let's see if there are some good opportunities to use AI wisely if we at least put the right controls around it. This is going to be an experiment. Hopefully it's going to be fun. Hopefully I don't break my environment on the first video, but we'll see. Alright, enough for disclaimers. Let's see what we can make, and let's see what we can break. So to start off with, I'm starting off with a brand new database environment. Has nothing in it. Alright, and we're going to try and create this environment from the ground up. And as we go along, we're going to create this, we're going to modify it, we're going to try and see what actually generally does work with it or not. So, worst case, if I break things, it's a sandbox environment intentionally for this. And as we go along with this series, we'll try and build it up and see how fancy we can get with this database in a reasonable amount of time. And obviously this is for efficiency considerations. So some of the goal here is, can we do things more efficiently? So blank database, let's talk about our scenario. So here, I'm going to be thinking kind of along the lines of AdventureWorks. So we want to create a database that is able to track things like sales, the products that were sold, the people who sold it, and the regions that they belonged into, so we can do some sales analysis from there. So let's even start with the basic prompt here, and I'm going to open up a new query window so I can give my SSMS Copilot connectivity into it. Now again here, the fact that it says Copilot in SSMS at the bottom here, this says that our Copilot does not currently have context to the database. I have to connect it to my query editor window. So I'll hit at, and see my new window I just opened up has that option. We'll hit SQL Query 14. Now it's got context to the database. Alright, it's connected now. Now let's start the database design process. So I have an idea for a database design. Maybe I have a diagram. I haven't written out any scripts or anything to actually create the database environment itself. Let's see if maybe Copilot can help us with that initial creation. So I'm going to go here and I'm going to say, alright, so let's go with this. Help me design a sales database schema that tracks products, employees, sales transactions, and the regions that my organization works in. Come up with an initial design for the database. Now, first thing to note here as we run Notice at the moment, I'm running in the default mode, which is read only. So at the moment, SSMS Copilot can't do anything to actually manipulate the database yet. Let's wind this a little bit and let's see what it gave us for a design. Alright, so an initial design for the sales database schema. Schema includes tables for products, employees, sales transactions, and regions, along with their relationships. So, first of all, it did think about things in terms... Oh my gosh. One moment. Okay, enough notifications. Let's take a look at the response that it gave us here. So some of the important things to note is that it did actually take an initial stab at normalizing things. It didn't just give me a flat table design that contains all those things. It actually did normalize it, which is good. Alright, we've got things like product IDs, product names, price, stock quantity, category, employee ID, first name, last name for employees. That's a good start. Let's see, sales transactions, transaction IDs, quantity sold, sold amount. Alright, and it did give me IDs that are at least foreign key references and its identifying those things here. It even went to the point of defining what are the recommended constraints that it would give me for those things, which is nice. It's giving me foreign key references in between tables and such. Alright, not bad for a first start. I'm going to see if it can actually create this schema. So I'm going to hit slash, and we're going to go to read write with approval, because we're not going to go super crazy with this yet. Create the database tables as per your design in the previous response. Alright, so trying to keep this simple, let's see if it can actually figure out what happened in prompt history and turn it into actual statements that create this structure. Okay, couldn't find that. Alright, so I'm going to hit the up arrow and let's bring up that previous prompt. So we'll just modify that to say that and create the tables within the connected database environment. Let's see if just with a minor adjustment it can create things. Alright, here's what it gave me, and let's zoom in here. Review carefully before executing. We're going to heed that, so let's review. Let's see, so things it did, product ID. So, nice things it did, it assumed that I wanted an integer identifier, uniquely identifying each table. Alright, that's all well and good, so it gave me an identity and defines it as the primary key. So that's going to define the constraint. That's good. Product name. And varchar. Okay, sometimes for application databases, people like keeping things simple and storing data in Unicode. Maybe in your use case, you're not wanting to store things in Unicode and you want to save some space, in which case, you've got that going for you. Price is here. Category, stock, quantity. Alright, good start. Regions. So again, a very simple database design here with regions, employees, foreign key constraints, and here's where it's giving me the prompt. Running this query will make changes to the database. Are you sure you want to run the query? Let's allow it to run. Gives me another prompt here. And let's go into our database. Alright, sure enough, it was able to create, for employees, we've got an employee ID. That icon says it did actually enforce a primary key. Region ID, products, regions. Everything looks like it's there, at least from an initial pass. Transaction ID. All right, that's all well and good on a lot of fronts here. But maybe this isn't exactly the design you wanted. Maybe we want something a little bit more complicated. Let's try and make this a little bit more complicated. So, something like my employees does not have managers. We typically have managers. So I want to be able to add managers in here. So let's do that. Let's say, employees in my organization have managers. Alter the dbo.employees table to include a manager ID. The manager ID will point to an employee ID on a different record in the same table. Pretty typical design. We get that foreign key relationship in there and problem solved there. Let's see if we can figure out how to make that work. Maybe if it adds in a constraint as well. Create tables employees, add manager into null, and it did actually add in a constraint that's going to reference that. So not only is it doing that, it's also going to enforce good constraints there. Let's go ahead and run that. And there we go. It made the adjustment. If I refresh this table. There we go. Manager ID and the foreign key constraint is defined. We've got our initial design here for employees. And I could further make adjustments there. So add columns to employees to store salary. So we want to know what their salary is. They have a hire date. They don't have a termination date. Termination date. Let's see. We have regions defined. We do have a connection into regions, so we've already got that established. What else could we use? Position has their title name. That's probably good for initials then. We'll just write that. So add columns to employees to store salary and termination date. Okay, adds that in. Decimal field for salary, makes sense. Termination date is a date. We're good with that for right now. We won't care about the exact hour that somebody was terminated. Don't need that. Let's run that. Alright, we've got some at least additional fields here. Now let's at least consider some things around database design. So, okay, we've got things normalized, at least reasonably normalized here. We've got columns that we could add in. We've got constraints already. We didn't necessarily have to specify anything there, so that's kind of cool. Partitioning might be something that happens if your data is a little bit larger. You might want to partition things, especially like our sales transactions. We may expect a lot of things. So let's see. Maybe Copilot can help give us a recommendation for partitioning. So I anticipate a lot of data. Or sorry, not a lot of data. Let's see. Let's try and make this a little bit more. I anticipate a large number of transactions being stored in dbo.sales transactions. Let's maybe see if it can even figure out what's a good partitioning strategy itself. So, recommend partitioning strategies for this table based on the columns provided. See what it comes up with. Partitioning is a useful strategy for managing large tables that can improve query performance and simplify maintenance. Yeah, that's why we do this. Based on the columns, here are some recommended partitioning strategies. Alright, range partitioning by date. Alright, so its top one is time sensitive, which we would expect to see. Like, it's not all that uncommon for something like transactions. We expect transactions to happen over time, typically happen sequentially, and because of that, partitioning by that transaction date makes a lot of sense. Hash partitioning by region. By hashing the region ID. Hashing the region ID. Not quite sure exactly why it would choose to do that. Just using the region ID as is, it's going to be an integer value, seems interesting. I don't know why you'd want to hash it. It's a natural key for the database. Let's see, composite partitioning if you wanted to do it by both. So considering doing both depending on that. We're going to keep it simple. We're going to just assume dates is going to be enough. We'll typically apply retention policy to a database like this, which means at some point, maybe some of those old transactions will roll off. Implementation steps for range partitioning. Oh! It actually created partitioning functions. So partitioning function, define the ranges. Interesting. So recommending it, not only did it do that, it also gives us a straight up plan for... It gave us a full plan for being able to take the existing table, create the partitions, both all the way from the partition function to the scheme that uses the function defined above, redesigns the table, and then even has it where it's creating it as a separate table so we can partition the data without retaining data. So it's assuming right now, even though we just created this table, that there's data in there and it's trying to preserve it. That is really cool. Let's see if we can do that. Execute the scripts generated from the previous prompt. Partitioning dbo.sales transactions by transaction date. Alright, so it's going to generate that. Partitioning the table requires careful planning. Provide the scripts and run them with approval. So it's trying to at least be acknowledging the fact that it can't necessarily run things directly without me doing anything there. Which is good. It's adhering to our guardrails. That's what we want to see here. Alright, partitioning function. So it is partitioning currently for monthly ranges. We'll say that's fine for right now. We're not going to have a whole lot of data in here, I expect, for sampling purposes. And let's see, created the partitioning scheme based off of that. I confirm these scripts and would like you to proceed with executing them. I approve this effort. Alright. Interesting. So, I would expect, at least from seeing the scripts there, that this would have worked, but it didn't end up working because it actually knew the environment I was in. So, newsflash, I wasn't planning on sharing this until later on, but I am currently running this on an Azure SQL database implementation within Microsoft Fabric. Which means there, the Azure SQL DB, while for the most part it does everything the same, it does restrict certain things. And this is a case where the database is there, they're trying to partition and index and perform some of these recommended things in that environment. And because of that, it's going to say, this isn't allowed for you here. But I think we can say too, from the scripts that are generated, I don't think it would have caused a problem if we would let it do everything here. And it makes sense that some of this would be more for on-prem environments, because you can see here, or not on-prem, but environments where you're actually managing the file groups, because you can see here from the partitioning, it actually is working with expected file groups and the like. But aside from that, the queries are on point, and it even stopped us from being able to do things and told us that in this case, what I'm trying to do isn't supported in my environment. I can assist you with alternate optimization strategies. So let's maybe ask it what context I can figure out for Fabric SQL database. So what optimization can I do to improve performance on dbo.sales transaction, knowing the environment I am currently working in. Again, here we're trying to test, is it able to figure out where it is and what its restrictions are. Okay, it does reiterate the fact that it's in a Fabric SQL database. And I'll have to compare this to the release notes for Fabric, and you would have to do this for your database environment to assess what it's telling me, is that what's actually supported. Fabric SQL, a bit of a newer feature, so some things like this not being supported isn't necessarily a surprise. If you're working in an on-prem SQL environment or other database implementations that are a little bit more, well, they're older, you might get some better things here. So indexing, it says I can do that here. Give me a clustered index. Query optimization. Avoid select star. Well, we always know that. So even here, for in terms of optimization, it's covering it from all the lenses. It's covering it from things that a DBA would do, indexing, things that query writers should do. Statistic maintenance goes back to the DBAs. In an alternative for table partitioning, you can simulate partitioning by splitting the data into multiple tables and use a view to combine them for querying or move older transactions. I mean, admittedly, compared to what you can do in other environments that support partitioning, if you're in an environment that doesn't support it, it does make a fair argument. You could essentially do what partitioning does, and you could break it out individual tables. That's a whole lot of extra work here, so I'm not necessarily too happy about that. But archiving data, old data, might actually work better. Something there, I can move old data into a history table and build a history table in here that works in that case. Do I want a history table in here for something like transactions? We're going to say no for right now, because I'm not necessarily confident I'm going to deal with enough of a performance constraint, but at least gives us some advice there. Compression, concurrency management. Like, saying this from a data engineer's viewpoint, this gives me a whole lot of things to think of, that when I design environments, I don't have a lot of time to think about this. I'm more thinking about what's the end goal design that I'm building, how do I get data from point A to point B, things like that. I don't always have a DBA readily available. And so sometimes you need that little extra guidance, and this is already giving it to me. Like, it's unfortunate that I can't do partitioning in here, but at least with not being able to do partitioning, I've got some ideas that I can work with of improving this. All right, last thing I'd want to do, and this is more from a data engineering focus, is this is designed as more of a like third normal form operational database environment, but I'm a data engineer. I work a lot with analytical environments, such as taking data like this and dimensionally modeling it. Could this take the structure and just dimensionally model my data? Let's see if it can. Given the current schema, create new tables that will store the same data as the current tables, but will dimensionally model the data. Organize dimension tables in a schema called dim, and fact tables in a schema called fact. And let's maybe think about things like SCD types. I might want to take something like employees, and we want to track their information over time. So let's... Products regions probably are not going to change too much, so we will leave those as is. So we'll say design dbo.employees as a... Sorry, let's see. Designed the dimension table. I'm trying to not give it too much context to see what it can figure out. Designed the employee table in the dimensional model to be a SCD type 2 table. Any other dimensions can be type 1, SCD type 1, and add metadata columns to store insertions, inserts, deletes, or sorry, we're not going to deal with deletes, we'll just do updates. Updates and SCD evolutions as needed. So, existing schema, we're going to try and design this as a dimensional schema. So this is going to have to do a number of things in this prompt. It's going to have to be able to create the schemas. It's going to have to assess what is being done as far as tables that should be dimensions, tables that should be facts, and then it needs to understand Kimball principles to be able to assess what I mean when I'm saying a type 2, which means if data changes, I want to capture the before and after of the record. Let's see. Okay. Prompt is running. Let's review what it came up with. So, below is the dimensional model based on the current schema. Data will be organized into dimension tables in the dim schema, fact schema. Okay, so it caught that. Dim employees table will be designed to slowly change dimension type 2. Okay. And it was pretty smart about that. Granted, this is a simple design, but it was able to call out these sorts of tables make sense as dimension tables. These tables, or in this case, one table makes sense as facts. So we've got a single fact star schema going on here. Table structures. It added in a surrogate key. So oftentimes we've got a natural key from our operational environment. We want to translate that into a surrogate. It was smart enough to realize that it needed that and documented it as such. And it's keeping that principle consistent across all of them. That's really good. Insert date, update date. It has for products. Looks like it added that in for regions. Employees, this is the one we said we wanted to do type 2. So how's it doing type 2? We've got an employee key. We've got our business column, salary termination date. Is current, so it adds in a bid flag for is current. That's cool. Effective dates. Start and end dates, inserts, and update dates. So the way it's planning on managing its type 2 is the key is going to uniquely identify an employee in the environment, and then it's going to use effective start dates and end dates to define those date ranges. Depending on how you want to design that, sometimes I would add in a secondary employee key that is exclusive to the version of the record, but you don't technically need that on that. So that's being a nitpick there, more in terms of design principles. And did the same thing for facts, and assumes that we're just going to be inserting transactions. Okay, maybe we understand that sometimes transactions need to be updated, so we can fix that. And I did provide that all in there. I'll create these. And then look at that. So it was smart enough to realize that it needed to create the schema for that just from the information that I provided. And then it's following things in terms of dependencies. Now, about the one thing that I'm missing here, and admittedly in analytical environments gets to be a bit of a nitpick, is that it's not adding in any... I stand corrected, actually, it is adding in constraints. It added in the constraint for dim employees, and for this as well. Now, admittedly, some people, when you're working in analytical environments, may be like, you may be working within your ETL process and modifying things in certain ways, and because of that, you don't necessarily want to enforce constraints. I'm kind of potato on that, but it's nice that at least its default preference is enforcing referential integrity versus ignoring it. For an initial design, again, simple, but not that bad. I'm going to go ahead and let it run. Alright, create schemas, create tables, create fact tables. Let's refresh our schema. Our schema of schemas, because we've got multiples in the same database. Doesn't look like they're showing up. Let's see. Did it create our schemas? It did not create our schemas. Why did that not? Let's see. Let's have a check. Double check your last activity in the database. You said you created the dimensional... You said you created the dimensional model, but I do not see the dim and fact schemas, nor the tables within the schemas. Alright, so checked. These dimensional model tables were not successfully created. Okay. Let's try running it again. See if I did it this time. Nope. Okay. Well, it seems to be struggling with that right now. So provide the script. Oh, it's already got the scripts up there. So I'm just going to take that, insert it into our window. It's not wanting me to create schemas. Oh, this is Microsoft. Sorry about that. Looks like my database recording, or my video software recording, my video recording software crashed on me. But I was able to at least ask the prompt of Fabric SQL databases, does it currently support creating schemas beyond DBO? And currently, no it doesn't. That's why that failed. Hello, I am Sven, and I am skeptical. DataBard makes this assertion that things like creating multiple schemas and such in Fabric SQL databases isn't supported. But that doesn't seem right. It's an Azure SQL DB implementation. That sort of thing should be supported. So I decided to investigate further, because I like to be thorough. Turns out DataBard's assertion here is inaccurate. When I go in and I run the statements generated by the Copilot, statement by statement, it runs successfully, and I can confirm in my environment that I have the appropriate schemas created, and also the tables that he said he couldn't create because they were in a separate schema. So, the script there works. Why the Copilot couldn't do it? I can't say for sure because I don't know what happened behind the scenes. But Copilot, in this case, hallucinated. It is possible to create multiple schemas in a Fabric SQL database environment, and I have proved it. Does that mean the Copilot is bad? No. What could have made this situation better? I think what would make it better in a situation like this is to keep your prompts simple. Let's not do too many things in one prompt, or it's very easy for even a portion of it to not come out the way you want, and because part of it doesn't work, the whole part doesn't work. Break your prompts into smaller chunks, and you'll have a better time having each part complete successfully. Just in the same way, for this query, I had to break it into smaller sections to get it to work. The Copilot had difficulty figuring out what to do. It's an AI solution, it happens. What's healthy is when we work with AI solutions like this, this is where we need to be skeptical. For that reason, I find myself saying, as always, Now, that's at least a edge case, but we can at least take a look at this structure and say, yep, this at least looks good in terms of what we would expect to have it define. So think about it. Within the entire demonstration that we've done here, we were able to ideate a schema structure. We were able to have it actually create the structures themselves, including key constraints and all of those things. We were able to make adjustments to the existing schema to add things after the fact. It was smart enough to at least know that if it was making certain adjustments for things like partitioning, and I would assume other things will follow suit, we can successfully have it create scripts where it knows to preserve existing data and do things like table swaps. That's not necessarily an easy process, and that takes a lot of time to write. So not having to write that easily saves a good 15-20 minutes of querying time, turns that into a couple of seconds. And then on top of that, I was able to take an existing schema and I was able to design a dimensional schema based off of that lets me start doing things like type 2 evolutions. That's a whole lot to be done in probably like 40 minutes here, where to do all the design work, write those statements and such by hand would take longer. And in comparison to working with it here versus in other solutions, like GitHub Copilot comes to mind. You could probably do this there as well, but GitHub Copilot, at least I'd have to double check. I don't know if GitHub Copilot currently has a way for you to directly interact with your database and make things there. But I assume with the recent updates it has, it's probably heading in that direction. But still, this is a leg above and beyond things like your ChatGPTs using your basic M365 Copilot. This is going to give you more efficiencies beyond that. That's about as far as I think we'll take the demo for this initial video. And initial thoughts, I think at least so far what's impressed me is its ability to be able to understand what a really good design pattern is. Foreign key constraints, primary key constraints, getting those things enforced up front, because sometimes they're really hard to add after the fact. I also like the fact too that being able to take one schema and quickly adjust it into something like another type of modeling scenario, so things like going from operational to dimensional model, some really good fundamental things there. And that's even with just some basic prompts and without me putting any really thought-intensive process into the design, which I'm sure the more I did that design work, the more I came up with more elaborate prompts about what exactly I'm looking for. This is probably going to help me get a lot of those things started. And especially too, nice of it to know that it's able to see very quickly what type of environment I'm going into, which sometimes you get into a brand new environment and it's not exactly clear, like what version of database am I dealing with, where is it deployed, is it cloud, is it on-prem. It's really nice to see that built in there. Probably a good place then to cut things here, and we'll pick up this environment where we're going to take our next step and we'll start building out test data, because we're going to want to make sure we can build some test data in here to test, does our database work as intended. Hopefully this video was helpful. If it does, you know what to do. Hit that like, subscribe to the channel, as this series is going to continue and we're going to keep building on this and seeing how SSMS Copilot reacts to some good prompting and database development. If you have specific questions, let me know. If you have certain things you would like me to test with SSMS Copilot as we build out this environment to see how it reacts, let me know in the comments, and that might help enhance future videos that come up in this series. For now, I'm Data Bard, and I'll see you in the next chapter.